What does the future hold for the growing season, cold nights, first and last frost, and precipitation? We're using daily temperature and precipitation records from the Las Cruces Airport Weather Station as well as from the New Mexico State University Weather Station. We're combining this with global climate model outputs for two very different future scenarios. A higher scenario, where we see a greater amount of change because we continue to depend on fossil fuels as our primary source of energy, and a lower future where we transition to clean energy and therefore we see less change. Let's see what happens. First of all, in terms of our average temperatures, we expect to see a decrease in cold nights. There's a noticeable decrease in how many average nights per year are quite cold, below 28 degrees, but there isn't a big change in how long these winter cold spells last. We also expect to see a longer growing season. If we define the growing season as bounded by the last frost in spring and the first frost in fall, we expect it to be quite a bit longer, by up to 6 weeks by the end of the century total. What about precipitation? We see a small increase in the days per year with heavy rainfall, but no change in the average duration of wet spells. We also don't see much of a change in average summer precipitation, but we do see continued risk of drier than historical summers in the future. Let's look at these results in more detail. First of all, what happens to cold nights? Here we define cold nights as nights with their temperature, minimum temperature, below 28 degrees Fahrenheit. In the future, we expect these numbers to go down. Let's spend a minute on this bar chart first, though, so you understand exactly what they're telling you. Each bar represents the average of 30 years. It starts in 1950 to 79, and it goes through to 2070 to 2099. The light blue is the average for the lower future scenario. The dark blue is the average for the higher future scenario. The gray is the average of the models for the historical period. Of course, there's not a scenario there because it already happened. And the black is the average of the observations. Now remember, the observations are what happened on one planet alone, whereas the bars are the average of all the different climate models, as if you were averaging a whole bunch of different simulated Earths together. So we don't expect the black bar to be exactly the same as the gray bar, but we do expect the black bar to be within the range of the gray bar. The range is denoted by those thin black vertical lines, which we call whiskers. And as you can see in both cases, the observations are at or within that range. In the future, that range shows the variation among the models. Some show greater change, some show less. Overall, though, we do see that starting over 60 nights per year, historically, below 28 degrees, we see those numbers declining to around 40 or 45 under the lower scenario and around 35 under the higher scenario by the end of the century. As I mentioned before, though, we don't expect to see the average length of those cold spells change much. Currently, the average length is about 3 days, and in the future, it's about 3.5 days too. What about changes in the growing season? We define the growing season as the last day in spring when it freezes, till the first day in fall when it freezes. This shows the projected change and the observed change in the last frost in spring. As you can see, there has been a very significant decrease in the observations, that's the black line, since the 1950s. Here, the black line is the observed trend. Then the thick orange and red lines are the long-term average from all the different climate models for the higher scenario, red, and for the lower scenario, orange. The red and orange shaded areas represent the range of all the different climate models. So really, you want to compare the black line with the shaded range, not with the individual thick colored lines, because those are the averages of the 10 different simulated Earths, so to speak. So what we see here is that a significant decrease has already happened. In fact, if anything, the climate projections actually underestimate how fast this change is happening. What about the first frost in fall? Well, we also see big changes there. It's gone from around the end of October to more like the middle of November, just over the past few decades. Again, we expect this date to become later and later in the year, but also again, it looks like the models underestimate the rate of change. What's the risk of a summer that's drier than the driest historical summer on record? This shows average summer precipitation, where we're defining summer here as going from May through October. So May, June, July, August, September, October. The black line is the observed precipitation. You can see there have been a number of very dry summers. The gray circle highlights the driest summer, and the gray line shows the average precipitation on that driest summer across the whole period. So you can compare any year you want to that line. Will there be summers just as dry in the future? It looks like the answer is yes. Will there be many more of them? Maybe a few more, but not that many. So we expect the variability we already see today to continue in the future. Finally, how will heavy rain events change? Here we define heavy precipitation events as days with more than 2.5 inches of rain in one day. Here we're looking at the number of days per year that currently have that much rain. You can see it only happens once every few years. 0.1 means it happens once every 10 years. 0.2 means it happens once every 5 years. 0.5, if there were any, would mean that it happened once every 2 years. So these days are extremely rare. And the projections suggest that they might increase a little bit in frequency. But as you can see, the variability is very high. If you look at those black lines or whiskers, you can see they go all the way from 0 up to almost 0.5 by the end of the century. That means that there's a big range in the projected changes. Why is there such a big range? Because these days are very rare. What about the average length of wet spells? The average length of a wet spell is about 1.5 days, historically speaking, and in the future it's about the same. Maybe around up to about 2 days, but we don't see a big change in the average length of these wet spells. So what do we see when we look at these results? We see a sharp decline in cold nights. We see a very rapid change in the date of the last frost in spring, both in the observations and the model projections, as well as in the date of the last frost in fall. In terms of precipitation, we see a small increase in days with heavy rainfall, but those days are already so rare it's going to be hard to tell the difference. And we don't see much change in average summer precipitation, but we definitely see the risk of potentially very dry summers continuing in the future, just as they have in the past. What do we see here? The implications for the future are that precipitation will continue to be highly variable, but the growing season is going to begin earlier in the year and last longer. Planning for these changes is important, because by taking them into account in our future planning, we can ensure that we're prepared for whatever the future brings.